Okay, good afternoon, class. So today we're just wrapping up. Hopefully in this lesson we can conclude this paper 2. You guys have written. So in question 4.2 we are told, prove the following identities. So in 4.2.1, of course we're going to work the left hand side. It's going to be a bit easier to work with. So tan can be written as sine over cos. So it's 1 divided by sine squared x over cos squared x. That's your divide line here. Minus cos squared x over 1. So this is the same as writing 1 divided by sine squared x over cos squared x. The question paper and memo can be found in the description box below. Let's change this to multiplication, tumble and times, and 1 multiplied by anything is that number. So it's cos squared x over sine squared x. Okay? Minus cos squared x over. So what's your LCM here?
Sine squared x.
Sine squared x. Okay? So this must be multiplied by 1, so it's going to be cos squared x minus, this must be multiplied by sine squared x. So it's going to become cos squared x times sine squared x. Okay. Now what? What is common? Cos squared x. So it's cos squared x into 1 minus sine squared x over sine squared x. People, this can't cancel. Huh? So what's 1 minus sine squared x? Cos squared x. So this is simply cos squared x. The cos squared x times cos squared x is cos 4x over sine squared x, which is the same as the right hand side. Yeah, any issues there? So the next question, 4.2, we are told again to prove the identity. So the left hand side equals the right hand side. This one you need to know. Of course, left hand side is equal to tan can be written as sine theta over cos theta. This is multiplied by the square root of. But then LCM inside this bracket of sine square theta. Okay. So sine square theta must be multiplied by 1. So 1 times 1 is 1 minus, that must be multiplied by sine square theta. Sine square theta. So sine theta over cos theta multiplied by. What's 1 minus sine square theta? Cos square theta. It's cos square theta over sine square theta. The square root of cos square theta is cos theta. The square root of sine square theta is sine theta. So that cancels. Cancel. We get an answer 1, which indeed is equal to the right hand side, which is of course 1. Okay. .3.1, determine the general solution. So of course we go out our reference angle. There's an arc sine, shift sine of 0.32 gives you an answer of 18.66. It's 18.66. People do not divide by 2 at this point. You take it to the quadrants and you ask yourselves in which quadrant is sine positive. Sine is positive in quadrant 1 and quadrant 2. So how do we get into quadrant 1? So it will be 2x is equal to 18.66 plus k times 360 divided by 2. So it's going to be 9.33 plus k times 1. Okay? Or quadrant 2, 2x is equal to 180 minus 18,66 plus k times 360. X works out for me. So it's 180 minus that answer divided by 2. You're 80,67 plus k times 180. Where k is an element of integer. Okay. Any confusion there? No? Come inside. Look at 4.2.3. So of course we need to change sine to cos so that you can form a trinomial. Okay. So this can be written as 1 minus cos squared theta minus cos theta is equal to 5. Get rid of the brackets. So 6 minus 6 cos squared theta minus cos theta minus 5 is equal to 0. So we got minus 6 cos squared theta minus cos theta plus 1 is equal to 0. Now I can use many ways. I can use the quadratic formula, I can use completing the square, I can use a silver calculator, or I can just do the factorization of a trinomial. So I'm just going to divide by negative 1, which now gives me 6 cos squared theta plus cos theta minus 1 is equal to 0. So for those of you who can't factorize the trinomial like this, you write on the side here as 6x squared plus x minus 1 is equal to 0, and you factorize. Okay? Which is going to give me 3x, 2x, 1 and 1. That is plus and minus. So x is going to be a third, or x is going to be negative 4. There we go. Cos of theta is equal to the third, or cos of theta is equal to negative 1. The question you should be asking yourselves, in which quadrant is cos positive? Okay? So the cos is positive in the first and fourth quadrant. How do we get in the first quadrant? Quadrant 1. It's going to be, you must work out the reference angle first, sorry. Jumping the gun here. The reference theta is going to be arc cos of the third, which gives you 70,53. Okay. So for the first quadrant, theta is going to be 70,53 plus k times 360. Okay. Or theta is equal to negative 70,53 plus k times 360, or 360 minus 70,53 plus k times 360. And in turn gives us 180. Oops. 109,47 plus k times 360. Okay. On the other hand, my reference angle here, reference theta is going to be, that's from your special triangles, and they give you 60 degrees. The question that comes to mind is which quadrant is cos negative? Those two. So we go. Quadrant 2 is going to be theta is equal to 180 minus 60 plus k times 360. Where theta is going to give you 120 plus k times 360, or quadrant 3 is going to be theta is equal to 180 plus 60 plus k times 360, which is 240 plus k times 360. The k is an element of? Okay. Then test on 240. Just check here. So it's going to be 6 open brackets sine that answer squared.
Your attention please, this is an urgent notice from the principal's desk. We need to inform all learners that they need to contact their parents immediately to come and collect them in the next 10 minutes. Our road down Isma Road is flooded, so it is urgent that they need to disperse of the school immediately. Learners,
So
please
stop
take
here.
note.
We'll just carry on,
You
conclude
need to
in our next
contact the
lesson.
parents so that they can come and collect you. School will be.
Okay, so we just have about 10 minutes, so this is wrap up. Instead of wasting our time. Yeah, so I just checked that that's in order. Don't have the memo with me, yeah? But the question paper and memo can be found in the description box below. So the question then says that hence solve for theta is an element of negative 180 to 180. So I must go with this general solution here. Okay? So what we say is theta is equal to, if I put 0 through here, okay, it's going to be 70,35. Okay? So theta is an element of 0,35. People, I made a mistake here. That was 360 minus 70.53 gives an answer of 289. 289, 47. I don't know how about that. That probably said 180 minus. Okay, sorry about that. But if I put 0 through here, if I put 1 through here now, it will be over that domain, over 180. If I put minus 1, it will be far under. If I put 0 through here, I'm going to get a value of 289, which is over 180. If I put minus 1 in there, I'm going to get negative 70,5. If I'm going to put minus 2, of course, under. If I'm going to put 0 through here, I'm going to get 120, which is not going to work. If I put 1 in, is even further. Now 120 will work. Because 120 is within this range here. If I put 2 in, it will be outside. If I put minus 1 in, I'm going to get negative 240. If I put 0 in here, I'm going to get 0 out. If I'm going to put minus 1 in here, I'm going to get negative 120. So those are your solutions to that number. Okay. Let's go to question 5, 5.1. So we're going into geometry now. In the diagram below, A, B, C, and D are points in the circumference of the circle center. AC and BD intersect at E. AB is parallel to DC, and BOC is 90 degrees. So this is 90. I'm just going to write this in. So if this is 90, then these angles are half of that, which is 45. Why? Angle at center is twice angle at circumference. Alright, first question. Determine with the reason 3 angles each equal to 45 degrees. So firstly, angle A is 45 degrees, so why? Angle at center is twice angle at circumference. Angle at center is equal to 2 times angle at circumference. Now D is also 45, same reason, or angles in semicircle. Angles in semicircle. It's coming from arc BC. You don't have to name the arc you're working from, okay? Yes?
Can you say on D equals 45 alternate angles?
Alternate. How can you get alternate angles? Or B? Yes? But you can't just say B because there is many angles at B. You have to say A, B, D. Say yes, A, B. O as well. You can't just say angle B. So ABO is ABE and not ABO. ABD.
Is it the same as ABG?
ABE or ABD? Okay. It's equal to 45 degrees. Why? Alternate angles with AB being parallel to DC. Or you could have said that ACD. Can you see this whole angle here is also 45? Okay. So there's 3 angles as requested. Let's go to number 2. 5.1.2, it says prove that CE is equal to DE. So if these lines were equal, then those angles would have been equal. So in order to prove those lines are equal, I have to prove these angles are equal. So I'm going to first say that it's 45 degrees. Why? So I say DCA. DCA is 45 degrees. Why? Can either say angles in the same segment or alternate angles with AB being parallel to DC. That's DC. Yeah? So now we say since DCA is equal to angle D, which is 45 degrees, therefore D is equal to DC. Why? Sides opposite equal angles. Okay. Yes.
So for D you said D is equal to 45 angle in the same circle.
Angle in the semicircle, angle in the same segment.
Same circle. Supposed to be in the same
Same
circle.
segment, sorry. I even named the arc. But yes, angles in the same segment. Okay. That was A. And look at B. So B says CD is the diameter. Now I must prove that that's the diameter of the circle. Let's prove that.
Your attention, please. When the bell rings now, it's only our learners that will be dismissed for today. Tomorrow will be a normal school day. We will assess it as the day goes by. Please take note, only learners are allowed to leave now. Thank you.
Okay, we'll carry on in our next lesson. Okay, good morning, class. So today we are looking to wrap up the June exam that you guys have written. Okay, we got up until question. Yesterday we got up until question 6. Let me check. 5. We didn't do the B part of this question. Okay, so it says here, CD is the diameter of circle passing through. So let's use the other color. So I'll take this question as whatever I've calculated here on the board. Let us prove that CD is a diameter of circle passing through ECD. ECD. So if this was a diameter, then angle E will be 90. Why? Angle in semicircle. So to prove that that is a diameter, I'm going to prove that this angle DEC is 90. Can you see that? The converse of that theorem there, which is angle in semicircle. So if we're looking at a triangle, DCE, CE, already we got this 45, 45. So we can say that DEC is equal to 90 degrees. Why? Sum of triangles. And that is triangle DEC. Okay. So that is 90. So since that is the case, therefore, DC is a diameter of circle passing through EDC. Why? It's either converse of angle in a semicircle or 90 degrees subtended by chord DC, or 90 degrees subtended by chord. Okay, that's how you answer the question. 2 marks. Yes? Alright. Let's go to the next question. Question 5.2. We are told that in the diagram below, A, B, C, D, and E are points and circumference of the circle. Then we are told that DC produced meets EF. BC produced and meet AE produced at D. Then we are told that AB is equal to AC. If AB is equal to AC, we know that B1 and 2 is equal to angle C1. Why? Because the angles opposite equal sides, and then we are told that angle is 35 degrees and A1 is 40. Alright, so with that in mind, let's answer the questions. So it says determine with reason the size of C1. Determine with reason the size of C1. So C1 is this angle here. But remember, we said that C1 has to be equal to ABC or B1 and 2. Why? Because it's angles opposite equal sides. Okay. So C1 plus this angle, which is also C1, plus 40 degrees is equal to 180. Why? Sum of triangles, it is triangle ABC. Do we have to name this triangle here? No. Okay. So 180 minus 40 is 40. Divided by 2 makes C1 70 degrees, which is also angle B. Okay. You can't just say angle B. Why? Because there are 3 different angles at B. Okay. Let's look at the next question. The next question says, B says, calculate A2. Angle A2, this is pull out the wrist. Calculate A2. So there is angle A2. So what you notice is that here we've got a big triangle here. Not so? So we can simply say that angle A2 plus 40 degrees plus 35 degrees plus 70 degrees is equal to 180. Why? Sum of triangles, it is triangle ABD. Again, you don't have to name this here. Okay, so angle A2 is equal to 180 minus 40 is 140. 140 minus 70? 70. Minus 35? 35 degrees. So A2 is 35 degrees. Okay. Any confusion there? No? Next question, it says hence. We're told that hence prove that BE bisect. Bisect means to cut in half. So prove that the BE bisect angle ABC. ABC. It doesn't look like it's bisecting. Sorry? What's 35 plus 30? Yeah, it is. B17, eh? Yeah, that's good. I'm thinking now, how are we going to get to? Okay. So 5.2.2. So firstly, this angle is equal to that angle. Not so. So B2 is equal to 35. Why? And it's in the same segment. And it's coming from arc CE. Alright, so we know that the B1 plus angle B2 is equal to 17 degrees. That was given to us. Or proven. Not given, proven. We've proven that this angle was 70. So therefore, angle B1 is equal to 35 degrees. Okay. So what do we say? We state the obvious, which is equal to B1, B2, sorry. So B1 is equal to B2, which is 35. Therefore, BE bisect angle AB. Yes.
Do we have to state the proven part?
Sorry?
Do we have to state the proven part again?
You should.
Plus, plus,
So you need a reason. Okay. Sorry?
It's already proven, it's the same question.
It's not, it doesn't matter.
Hence,
Doesn't matter. Because it's different to that sum. If it was part of this, then I don't have to say proven. Okay. But because it's a different sum, would have to state. Did you lose one mark there? Okay. Which is correct. Okay, so thank you for picking it up. Are you going to make the same mistake again? No. People rather write a little bit more in geometry than this. Okay. Especially in the prove that or show that question. We always try and show more. Okay, because the answer is on the board. Sorry, on the question. Okay, the answer is on the question, so and it's 4 marks, so we're going to place it 4. You understand? People, we are told that in the diagram O is the center of the circle. So O is the center of the circle. A, B, C, D are points of the circumference of the circle. E, O, B is a straight line with E on AD. Then we are told that AB is equal to BC. If that's the case, then C1 is equal to A1. Why? Angles opposite equal sides. And then we are told that B2 is X. So there's X there. Alright. First things first. Question says, a little bit smaller. Answer the questions as follows. Show that angle O1 for 2 marks. Show that angle O1 is 180 minus 2x. Alright, so O1 is lying here. Not so? But because OB and OC are radii, which means to say that that angle is also x. Not so? So we're going to firstly say that BCO is equal to x. Why? Angles opposite equal sides, and is also your radii. Not so? So now I can go with summing triangles. Not so? The angles in a triangle adds up to 180. So angle O1 is equal to 180 minus x, which is 180 minus 2x. Why? Sum of triangles in this triangle, BOC. You see, this again is show that question. So here you're going to get a mark for your reason. This is statement and reason must be given to get that 1 mark. Okay. Let's look at 6.2. So this is now 180 minus 2. Got the next question. 6.2. Calculate with reason angle A1. 2 marks. Calculate with reason the size of angle A1. So this is the quiz A1. So, hey, here's A1. But A1 is the same as C1. Not so. But we don't have C1. We have the combination of C1 and 2. However, we know that angle at center is twice angle at circumference. Can you see that arc BC is subtending the angle at center, and that same one is subtending the angle at circumference? Not so. So A1 is a half of angle O1. Okay. So angle A1 is going to be 180 minus 2x divided by 2, which is 90 minus x. The reason? Angle at center is equal to 2 times angle at circumference. Okay. So this is now 90 minus x. If needed, that angle is also 90 minus x. You see that, people? Look at the next question. 6.3. Show that question again coming up. Show that to prove that. Okay, so whatever we have calculated thus far is on the diagram. Okay? So let's take this off. Alright, so here we are asked to show that EB bisect. So EB bisect ABC. So in other words, if we can prove that B1 is X, we've done the job. Not so. So if we look at this triangle here, what do we know? We got it, there's 90 minus X if needed. We got that angle, we got this angle. So in other words, sum of triangles can work to calculate B1. Can you see that, people? But I first need to work out to state C1. So we firstly say that C1 is 90 minus X. Why? Angles opposite equal sides. Okay. Now we say that B1 plus X plus 90 minus X plus 90 minus X equal to 180. Why? Sum of triangles, and it's triangle BAC. Okay. The angle B1 is equal to 180 minus X minus 90 plus X minus 90 plus X. I'm taking everything to the right hand side. 180 minus 90 minus 90 is 0, minus X plus X plus X is X. So B1 is actually X, which is equal to, since B1 is equal to B2, which is equal to X. Therefore, EB bisect angle ABC. Okay?
So could you have proof of congruence?
If you're going with congruency, I also tried earlier on, because this is in the grade 12 paper as well, to prove congruency here. But what do we need for congruency? It's either side, side, side. We have that side, we have this side, we don't have that side. So side, 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 one. Side, angle, side. It must be the included angle. So we got the side, yes. We know that is your adjacent, that is your common between the two triangles. But do we have B1 and B2? No. So you can't use side, angle, side. You understand? Then you could have used angle, angle, side. That means you say I must have two angles. I got that angle, yes. Do I have a P1 and 2? No. So I can't go side, angle, side again. Angle, angle, side. And RHS, we don't have the right angle there, so I can't use RHS. So could we have used Pythagoras here? No, we don't have enough information to calculate Pythagoras. Using Pythagoras. You understand? Any other questions? No? Next question. It says prove that. You've got to love this prove that, show that questions. No? Because people, the answer's on the board. You're making life so easy for us. Not so. So here you're asked to prove that DEOC is a cyclic quadrilateral. So how do you prove cyclic quads? One of three ways. Okay, so what? Let's first go investigate what they're asking us. DEOC. To prove that the cyclic quad is one of three. Exterior angle is equal to the interior opposite. Which could be the case. You can see that's clear. Not so? So, it's either that or opposite angles are supplementary or the bow tie. But there's no diagonals here, so I'm not going to use the bow tie. Okay. So if I can prove that angle D is 180 minus 2x, I've done the job. But with further investigation, what do I see? I actually see as a cyclic quad D already. Not so. So in other words, D plus that angle B1 and 2 is going to give you 180. Why? Opposite angles of a cyclic quad. Not so. It's supplementary. So I'm going to say that angle D is equal to 180 minus 2. Why? Opposite angles of cyclic quad. So it's 180 minus 2x. So hang on. Exterior angle is equal to interior opposite. Not so? So we say, since we state the obvious, angle D is equal to angle O1, which is equal to 180 minus 2x. Therefore, DEOC is a cyclic quad. Why? Because exterior angles equal the interior opposite. Okay, the exterior angle is equal to the interior opposite angle. Any confusion there? Look at 12 paper. 12, 12, 12. Any confusion there, people? Yes, they do. The question paper and memo can be found in the description box below. Alright, so let's carry on with the lines. Question 7, 7.1. Here we are asked for 4 marks. We are told that ABC is a tangent. People, if ABC is a tangent, what do we know? We know that B1 is equal to angle D1. Why? Tan theorem. You also know that B3 is equal to angle E. Why? Tan theorem. Then we are told that BE is parallel to CD. What can be shown here? That D2 is equal to B2. Why? Alternate angles here. Not so. What else do we know? Angle C is equal to A1. Why? Corresponding angles. Prove that D1 is equal to C. So already more. Finish it then. D1 is equal to C. So where do I start? I bring my x into it, not so? Every opportunity we have, we bring our x into the story, not so? So we say, start with D. Or you can C, no? But we say let angle D1 equal x. You don't have to always bring your x into it. Okay, this just make life easy for us. Okay. So if d1 is equal to x, which are the angles equal to x? B1. So angle B1 is equal to xy. Tan cotherum. Tan cotherum. Right. Then angle C is equal to xy. Corresponding angles. With CD being parallel to B. So therefore, angle D1 is equal to angle C, which is equal to. Imagine it's so easy. Can't get any easier than this, no? 7.2. 7.2, we are told that AQ is a tangent to circle. AQ is a tangent to circle at Q, supposed to be at Q, not in Q. And so if it's a tangent, what do we know? Q2 is equal to angle P. Why? Why is angle Q2 equal to P? Tan cotherum. Not so. Then QP is parallel to AR. So can you say from here? Angle P is equal to angle PAR. Why? Alternate angles. Now it says prove that RA is a tangent to a circle through ABQ. People, if this was a tangent to the circle through QBA, then we know that this angle would have been equal to that angle. Why? Tan cotherum. Now in order to prove this is a tangent, we now prove that that angle is equal to that angle. Okay, you guys understand? Let's go. So where do I start? I say let Q2, let angle Q2 equal x. So there's your x. Now what? We say that angle P is x. Why is angle P x? Tan cotherum. Okay. And then we said, now you can't just say angle A. You must say PAR. PAR is equal to XY. Alternate angles with QP being parallel to AR. Now I can say, since PAR is equal to angle Q2, which is equal to x. Since that is the case, therefore, AR is a tangent to circle through QAB. Why? Because angle between line and chord equals angle in alternate segment. Or you could have said converse to tan cotherum. Okay, converse of tan. Any confusion there? Easy. The bonus question. Oh, is the center of the circle? Oh, this was the proof. Not so? So the proof can be found in the description box below. Okay? The link to the proof can be found in the description box below. Alright. That basically brings us to the end of paper 2. Okay, the question paper and memo can be found in the description box below.